In this lesson, we're going to prove the mean value theorem. So we, first of all, assume that f of x is a continuous function on the closed interval a, b, and that it is differentiable on the open interval a, b. We want to show that there is a number c between a and b in which the derivative of f at c equals f of b minus f of a over b minus a. In other words, the derivative of f at c is equal to the slope of the secant line. Now, what we're going to do is we're going to go back and use Rolle's theorem. So we're going to construct a function that utilizes Rolle's theorem in order to obtain this result. So consider this function. G of x equals f of x minus f of a minus x minus a times, and then we have the slope of our secant line here, f of b minus f of a over b minus a. Now, this may look a little strange, but it works perfectly. Notice several things about g first of all. So let's note g of a. If we put a in here for all of the x's, we get so notice that having put a in for x, we get that everything is equal to 0. So we get back 0. Also notice if we put b in for x, we get f of b minus f of a minus f of b minus f of a, because the b minus a's cancel, and we get back 0 also. And let's note two other things about g. First of all, g of x is going to be continuous on the closed interval a, b. Now why is it continuous? Well, if you look back at how g is defined, it's a linear combination of the function f of x and the linear function x minus a times a constant. So this piece right here is like c times x plus some number k. This is a continuous function everywhere. The f of x is continuous over the closed interval a, b. So g is going to be continuous over the closed interval a, b. Also, g of x is differentiable on the open interval a, b. Now, why is it differentiable on the open interval a, b? Well, if we look at the derivative of g, let's note that g prime, well, that's going to be the derivative of f minus, now what we have here, this piece right here, well, let's first of all note that the derivative of f of a is 0 because that's a constant, so we don't need to worry about that. Now this piece right here, that's like negative x minus a times this constant right here. Just call that c for right now. Now the derivative of this function is going to be, well, let's note first of all that let's rewrite it like this. Negative c times x plus ac, and when we differentiate this we get negative c, right? The derivative of this is negative c, where c is this value right here, the slope of your secant line. So we get that the derivative of g is f prime of x minus this constant right here. And this value certainly exists on the open interval from a to b because we assume that f prime exists on the open interval from a to b. So now what we can do is we can apply Rolle's theorem. And Rolle's theorem makes a statement that there exists some number c between a and b. So there is a c in which the derivative of g at c is equal to 0. So if we put c in here for x, and now we just take this term over to the other side and we obtain that and there you go. We have obtained the conclusion of the mean value theorem. We've proven that there is a c value where the derivative of f at c is f of b minus f of a over b minus a. And so we did it by constructing this strange looking function, this g up here, and then showing that we could apply Rolle's theorem to this function. And that concludes our proof of the mean value theorem.